Hey guys, so what we're going to be starting today, we're going to try to finish up our notes in 4.5 by going over just some general questions that are going to put all of the things we've learned together in one problem. So let's start with our first problem. We have sine of 2x plus pi. We're going to establish some things before we graph this. The first thing I want to establish is probably what is the period of this function? And the period is found by taking 2 pi and dividing it by b. In this case, we can see that b is the value in front of x, and that is going to be 2. Therefore, our period should be pi. From there, we're going to try to figure out what our quadrant is. That's probably the most important step here because it's going to be how we scale things. So our quadrant is always going to be our period divided by 4. In this case, our period is 5. 5 is pi divided by 4. From there, let's establish also the amplitude. The amplitude we can see is the number in front of sine, which is implied to be 1. We can also establish if there's a vertical shift, which we can see there is not. We're not adding anything to the end or front, so there is none. And lastly, we can talk about the period shift or the phase shift, which is that newer concept here. To find the period shift or the phase shift, we're going to set the inside equal to 0, so that's 2x plus pi. And if we do some subtraction and division, we get negative pi over 2 equals x, which means we need to be moving left pi over 2. Okay, so for the first thing to start this problem, we're going to focus on the most important piece of information, which is actually the quadrant. I want you to scale your grid using pi over 4 as your tick marks. Okay, so you should have the following scale. From there, I'm just going to, just for the sake of the next couple problems, I'm going to scale this as being 1 and this as being negative 1. It's just going to fit the rest of our problems a little bit better. There's really no rhyme or reason to that. All right, so let's go ahead and start here. I know that this is a sine function, but we also need to move left pi over 2. So the first thing on my docket is establish, okay, is there a vertical shift? There isn't, so I can take that off my list. We already did the quadrant, so the next important step is to establish the period shift. Typically, sine is going to start at the origin, but not this time because we need to move left pi over 2. So I'm going to literally take this point, pick it up, and move it left pi over 2. Okay? From there, we're actually ready to start graphing. Sine, and I'm not going to draw quadrant lines here because they're the tick marks, but we will in future problems. Sine is going to start at the midline. It's going to go up to a maximum. Remember, its amplitude is just 1, so it's just going to go up 1. Come back down to the midline, down to a minimum, back up, etc., and you should get the following. So this right here is the graph of sine of 2x plus pi. All right, so let's move on to something a little bit more challenging. The next graph that we have here, I'm going to establish it as being blue so we can distinguish it. We're going to answer the key questions again. So the first key question I want to figure out is the period. To figure out the period, we always know it's 2 pi over b, but b is a little bit harder to find this time. B is always the number in front of x, but x is being divided. So another way to write x over 2 is to say that it's 1/2 x, and therefore b must be a half. So if I plug that in, I'm going to get 2 pi over 1/2, and we'll end up getting, if we keep it, switch it, flip it, we'll get 2 pi times 2 over 1, which is 4 pi. So our period is 4 pi. From there, we're going to establish the quadrant. The quadrant is always the period divided by 4, and so our period is 4 pi. Divide by 4, and our period is our period is pi, which is probably the most important piece of information typically, but we already have a scaling, so unfortunately, to save paper, we're not going to be scaling it by pi. We're going to have to work with what we have. All right, after that, let's figure out what the amplitude is. The amplitude is going to be the number in front of cosine, that's 2/3. That's how high it's going to get from the midline. And lastly, vertical shift. We actually don't have one here. We're not adding or subtracting anything to the outside, and so we can say no vertical shift. All right, so actually the last one here is the period shift or the phase shift. We can set the whole inside equal to 0, x over 2 minus pi over 4. If we move some things around, we get pi over 4 is equal to x over 2. If you multiply by 2 on both sides, you should get pi over 2 as x, which means we need to move right pi over 2. Okay, so we need to move right pi over 2, and that's going to be helpful. So let's go on to our graph and graph this. Okay, so the first thing that we want to establish here in our graph, well, we can't do the quadrant because we already made quadrants, but we can certainly pick out some quadrant lines. But in order to do that, we've typically started our quadrant lines on the y-axis. But we can't do that this time. And the reason we can't do that is we first need to move right pi over 2. So let's think about where cosine should start. Cosine typically starts, and not typically, it actually always starts. Cosine always starts on a maximum. And so cosine needs to start up at a max. The highest it can go is 2/3 from the midline. So maybe we estimate it being here. But that's not actually where cosine is going to start because it says we need to move right pi over 2. So I'm going to take that point and I'm going to shift it right pi over 2. From there, we're going to create our first quadrant line. That's kind of like our anchor point. So we can't make the quadrant line on the y-axis because we actually shifted our starting point somewhere else. So now let's establish what our quadrants are. Our quadrants need to be pi in length. So think about what pi is in length. Well, pi over 4 plus pi over 4 plus pi over 4 plus pi over 4 is pi, right? So if I have 4 pi over 4s, it should give me pi. So if I move 4 tick marks from my new quadrant line, I should get our next quadrant line. So let's move 1, 2, 3, 4 to my new quadrant line so that I have a length of pi. 1, 2, 3, 4 the other way. So I have a length of pi. And I don't think this is going to quite fit, but I'm going to try over there. So this is going to be a very, very stretched out function. So let's go ahead and start it because we have everything we need. We're starting once again at this pi over 2. So maybe I should make this point black because we're not actually starting there. Cosine starts at a maximum. It goes down to the midline, but the midline's not here anymore. The midline, or our next quadrant line, is actually going to be all the way over here. And that's all the room I have on this side, so let's go the other way. Cosine's going to come down to the midline in this direction and then come down to a minimum all the way over here. So we can't even get a full period of cosine because it's that large. And this right here is actually going to be the graph of cosine. So it's super, super stretched out. It's not quite as tall, it has a smaller amplitude. And that's the graph of 2/3 cosine of x over 2 minus pi over 4. So let's try the next one. Okay, so for this last one, I'm going to go ahead and graph this one in red so we can see it. I'm also going to change it ever so slightly so that it actually fits on our grid. Let's change this to 1, otherwise it's just not going to fit very well. All right, so what I want to establish first is I want to establish the period. Remember that the period is always going to be 2 pi over b, and therefore we're going to have 2 pi over 2, right? So that's going to be 2 pi over 2. In fact, we can kind of see right away, before we do all of this work, notice how the black graph is literally almost the same as the red graph. And so instead of doing all this work, we could establish that the only difference between the black graph and the red graph, the only difference is that this one is shifted up 1. So maybe let's save ourselves some time. This one's shifted up 1. Let's save ourselves some time. Let's graph the red graph using the black graph. Okay, so our black graph is listed here. The only difference between the black graph and the red graph is that the black graph is on the x-axis and the red graph has a new midline. The red graph is going to have a new midline at 1 because it got shifted up 1. From there, the red graph is going to be the exact same as the black graph. We just need to shift all the points up 1. So here's our first example. Take this first point here, shift it up 1. This is 2. Take this point here, shift it up 1. Take this point here, shift it up 1. Shift up 1. Shift up 1. So just keep doing that for all of your points. So keep shifting up 1 like this from all of your points. And you should get a graph that looks something like this. You can kind of see it's the exact same graph. It actually looks really pretty. I like that look. It's the exact same graph. We just shifted it up 1. So that one is actually kind of a gimme. All right, so let's move on to our very last question type. Okay, so the last question type, I'm just going to make one up, and the one that I made up is 3 cosine of pi x over 2 minus pi over 2 plus 1. So in essence, this is a nice example. In fact, let's make it negative just to make it even better. We're going to put all of our pieces together for this last question. So we're just going to approach this like we always would. We're going to first establish, okay, what is the period of this graph? Well, the period is established by taking 2 pi over b. b right here is actually pi over 2. And so we're going to say 2 pi divided by pi over 2, which if we keep it, switch it, flip it, is going to be 2 pi times 2 over pi. And you guys can see the pi's cancel. And so we're actually just left with 4. I don't think we're going to use this spot anyway, so we're good. So let's go ahead and find the quadrant next. Our quadrants are always the period divided by 4, and so our quadrant must be equal to 4 divided by 4, which is 1. Okay, so then let's go down here. I guess I already made some space here. Let's figure out what our amplitude is. Our amplitude in this case is going to be the number in front of cosine, but it's always positive, so we're going to say it's 3. We can replace the period with maybe the idea of reflection, and we can see that there is going to be a reflection. Specifically, it's always across the midline, not necessarily across the x-axis because of this negative. So we can say that there's going to be a reflection specifically across the midline, whatever that might be. There is a vertical shift. It is going to be going up 1. And there is also a period shift. If we set the whole thing equal to 0, we get pi x over 2 minus pi over 2. If we solve that, we get pi over 2 is equal to pi x over 2. Multiply by the reciprocal, 2 over pi on both sides. And if we do that, you should get that x is equal to 1, right? Those are actually reciprocals of each other. And therefore, we need to move right 1. So we need to move, let's make sure that I can actually see that when we do that. We're going to move right 1. All right, so let's try our hand at graphing this. So the first thing that I want you to do is I want you to take a look at the quadrant, because we're just going to graph one graph this time. Use the quadrant to scale your graph. So start with that. Okay, so we should have a graph that looks something like this, and I wrote all the information on the side just for us to kind of reference. Okay, so the first thing that we always start with, we started with quadrant, we did it. The next thing I want to do is I want to talk about the vertical shift. There is one here, which means we're going to disregard the x-axis as being our midline, and we're going to establish a new midline as being at x is equal, as y is equal to 1. Okay, so we're done with the vertical shift. We have the quadrant. Let's talk about next, that is kind of done too, the period shift. Okay, we have a period shift of x is equal to 1, which means we need to be moving right 1. Well, the original graph is a cosine graph. So remember, the original graph is a cosine graph, and cosine always starts at a maximum. So let's start with what the cosine starting place should be, and then we'll shift it. Okay, so in theory, cosine has an amplitude of 3, so from the midline, I should go up 1, 2, 3, and this is where cosine should, in theory, be. But it's not going to stay there. We need to move right 1. So I'm going to pick this point up, and I'm going to move it right 1. In fact, even to help me, I'm going to establish some quadrant lines just to kind of keep me on track. So go ahead and do that. Okay, so we've moved our theoretical starting place over. In fact, I'm going to actually put that in black because it doesn't really exist anymore. It's not really our starting place. So our actual starting place is going to be up at a cosine maximum, and I'm disregarding the negative right now. I know you guys are all thinking, well, what about the negative? I'm just going to graph the positive first and then take the negative at the end. It's just going to be way easier that way. So let's go ahead and graph the positive first. So cosine has an amplitude of 3, vertical shift up 1. I've already shifted right, so I'm good to go. Cosine is going to come down to the midline, and then it's going to go down to a minimum. But remember that your amplitude is 3, so I need to go 1, 2, 3 down, actually to -2. And you'll know if it's wrong. It's not going to look symmetrical if you don't do this. It's going to come back up to the midline, and it's going to come back up to a maximum, and I'm going to continue that out. Okay, so here's our cosine graph. We are literally almost done. The very last step that we have is we know that there is a reflection across the midline. So be careful here. We're not reflecting across the x-axis. We should reflect across the midline. So our total answer is going to be the red answer. I'm going to take the negative. So to reflect across the midline, we'll think all the midline points are going to stay the same. If I reflect them across the midline, they stay there. All of my maxes are going to turn to mins when I reflect across the midline, and all of my mins are going to turn to maxes. So go ahead and put some little points in there so we have a little bit of guidance on what this should look like. Okay, so we should look something Should be looking something like this. So to totally draw this, it should be a total reflection of the graph we just did. And your graph is going to look something like this. So our total answer for this crazy problem of negative cosine of pi over 2x minus pi over 2 plus 1 is going to look like this. So it's the red graph right here. Took a lot of work, but definitely doable. All right, if you have any questions, feel free to send me an email, send me a remind, and I'd love to help you.